Is it okay? Okay. I'll share my screen. Mm. Okay. Can you see the pen? Yes. Okay. See the screen. All right. So before we start the lab session today, I'm going to explain a little bit about the concept of Linguist. Okay. So as I've mentioned in first year, no, not in first year, in first semester, fundamental of programming is basically teaching us how to do something. Okay, like how to do programming in Java. Okay, how to make a program in Java. But in data structure class, we are going to learn why we are doing that. Okay, then how are we going to do it in a more efficient way? So the reason why we are learning this is because of the data management. Basically, data structure is about sorry, I spent like a few minutes first to explain a little bit about the concept. Then maybe we can learn more in the lab questions. Yeah, through the lab questions. So yeah, basically the data structure is about managing your data of your program, and the data is not persistent. So it means that once you open the program, then that you can generate some data and so on and so forth, or asking for user input. Then once you close the program, then the data is gone. The next time you open the program, you cannot fetch the data already. Yeah, so this is the data management in the memory side. So let's say if my program is provided this size of resource. Yeah, so these are the processing power or the storage that the memory size that a program can have for a Java program, right? So previously we learned about managing data as a collection via array, right? So let's say we allocate an array with a capacity of 5. So this is an array. Then we manage the data inside. Like this is the first value, then second value, and sort by index. So at the very first time, we are already provided this kind of capacity that we can fit whatever items that we need. Yeah, but array is not necessarily efficient if we want to use array for all the situations. So how can we define that if array or array list is better than linked list, right? So array list is actually same concept as array, but also it depends on your implementation. So array list is it hides the complexity of array, and it also have a capacity inside. But if you exceed the limit, let's say you dot add, you want to add another item here, you will copy the entire array, then put it into a larger container. Yeah, so this is for array list. But array has a huge issue in terms of writing, right? So let's say if you still remember the Viva, then let's say we have this block of array, right? Then we want to remove something. We want to remove the items here. Once we clear it, this is not done yet, right? We make the item out, then this will be an empty space. Then after we remove the item in that particular index, we need to move whatever items from the top to bottom. So this is a huge cost in terms of write. Although when you want to reading something by your index, it is easy because array is just fixed. So you can access any items by the index itself. So in short, if your program, your particular data, it requires many reads and less writes, then yeah, it's better for you to use array. But there are situations where your program might undergo a huge amount of write, right? Then this might not be a good fit for you already. Then how are you going to link those variables that they are in any way of your memory, right? So this is, let's say this is X, then this is Y, and Z, and so on, right? A. If you want to link these variables together, so here comes the linked list data structure, right? So in this variable, we just add another pointer that points to the location of the next variable. So this is linked list, right? So we are able to get the capability of linking between variables. So by doing these kind of things, as you can see, for the linked list, the memory address of each and every node, because there's a node, is different, right? So it can be in anywhere of your memory. So in order to get to any point, you need to traverse from the first node, then to the second node, then to the third node, right? So when your program, when your data, you need to manage it in a way that you write it a lot, then linked list will be a good fit to you, right? Because let's say if you want to remove something in an index, right? Let's say if you want to remove y, you just point the pointer here, then remove this too. Then your y will be isolated. The other list is still going on. Now you already reduced the size. This one you can choose to dispose it, or you can just ignore it because the linked list will not include y already. So this is when your data, you need to manage it in a way that you have less reads compared to writes. Yeah. So there's a basic guideline of when you should use array list and when you should use linked list, right? So this is a rough concept. Then I hope that when you're learning the data structure, you don't simply follow the codes only. You need to be able to implement in your own way. So let's say you are not given any kind of source codes for implementing linked list. As long as you got this concept right, you should be able to get the algorithm correct, right? So every time remove, then you change the pointer. Every time you add, you change the pointer here to point to another variable, and this one you point back to the sec. So these kind of things are called concept. Once you get the concept right, then it shouldn't be a problem for you to tweak the data structure to fit your own need. Yeah, because there might be cases where because I'm not sure, now you are in online learning mode, maybe the people who draft the examination questions, they might assume that you have access to all of the internet resources, such as you are able to get some kind of generic linked list or generic stack implementation via Stack Overflow or something like that. Then the questions might become quite tricky. So if you cannot get the concept right, even if you get the source code of a generic linked list, you won't be able to solve a specific problems that require you to tweak this underneath implementation, right? Also, when you are reading the questions, you make sure that you need to make sure that not make sure that you can try to start thinking. Yeah, it's never early to start thinking. You can think if the question is well drafted or not. Yeah, if in that circumstances, uh, is it really good for us to use linked list as a data structure, right? So these kind of things you can think when you are doing the lab questions, right? So we'll start with the lab now. Now we'll stop sharing because Wai Xiong will continue the last week's lab 4 question 1. Yeah, I hope you understand the concept that I've been mentioning just now, right? Stop sharing. Wai Xiong can continue.
Okay, good morning, everyone. Okay, for last week, right, we are doing for the question 1, and we complete for the A and B, which is you are able to push the random number into the back of the linked list and also in front of a linked list. So let's continue to question 1C, which is you need to insert a random number in a sorted linked list. So for every element when you insert inside, you will sort it into, let's say, ascending order. So for this part, in your linked list, you need to implement the generic type. They need to have they need to extend comparable, because not every type you can like directly compare, right, integer or double. So you need to use comparable to compare which which elements should be put in front, which should be put behind. Okay, for the add sorted, so probably you need you are looping from the head of the linked list to the end, which is to the tail, and you check one by one until which of the element the value is become bigger than the one you want to insert. Then you have two pointer nodes, which is one we call current node, which is the node that you want to compare the value. Another one is the previous node. So for this situation, because we are using single linked list, so we may need to have a pointer of previous node, so that when we want to insert the value, we can easily find the node which is should be behind the value that you want to insert. But if you are using double linked list, because double linked list you will have a node before and after, so you don't need to have this previous node pointer. So when you start to compare, so we will put current node equal to the head, which is the first one. So if the head is equal to null, so that means there's no any value existing inside a linked list. So you will just call the add method. You add the element like a normal operation. So if the head is not equal to null, that means they have some value inside. So you start with the current node is the head, and you compare the value with the current node. See which one is bigger. So if this one is so as an example, if the value is smaller than the current node, which is the head, so the current value will become the head of a node. So in here you need to do some sort of checking. So if previous not equal to null, so that means after you compare the value, you found that this the value that you want to insert is the smallest value. So if you don't have any value will be at the back, at the front of the value. So the head will become the value will become the head of a linked list. And also you need to check at the end. So when we compare the value in the while loop, so if we found that the value that you want to insert is bigger than the current node, so you will put current node equal to current node next, the next of the current node. So on some point when you reach the tail of the linked list, the next of the current node will be a null. So if the current node is equal to null, so that means you already reached the end of the node. So this means the value that you're gonna to insert is the biggest value. So you will put a tail is equal to the value. So until now, all okay? Okay, so we can confirm whether the operation is correct by implement it into use it in our main class. So last week we have done for the insert to the back and also insert to the front. And now we add on for another one is insert with sorted add sort. So we generate 10 random numbers and we add to the three linked list one by one. But one we're using add to the behind, one we're using add first, and another one we're using add sort. So when you see the insert with sorted, so when you insert the value, it will sort based on the ascending order. Okay, any question for the add sort method? If no, we will proceed to next question.
Okay. So I will continue with the question 2. Right. Entire screen. I'll share my screen again. Right. So, okay, I think you can see the screen now. Before we continue again, I want to go into a more detailed one. Okay. Right. So just now we okay. Just now we just explained about roughly the difference between linked list and array list, right? So this is linked list. Right? We have some kind of pointer to the next node. When you're studying the concept, try to be as simple as possible, and easy and as understand as possible, right? So don't complicate yourself with some random terms. Right? So this is array. So you have item 1, item 2, item 3. Right? When you want to read this is index 0, 1, 2. This is array. When you want to read the array, you grab the index, then you can get the location already. So reading with array is very fast. Okay, reading is fast. But with linked list, you can see here, this is item 1, item 2, item 3. Then when you want to read, this is index. When you want to read the item in index 1, you need to go from the beginning, right? You need to go from 0, then you find the next position, or here. Then only you can get a value. The reason is that, as I have mentioned just now, in array, you have a fixed memory location, or a collection of things in the same place. All are arranged in the same place. So you are easy to access by address. Yeah. So for example, this is a row of houses, then it's easy for you to get the address by the house number. But for the linked list, you will have all the houses are in isolated location. Yeah, they are different. So you cannot just assume that you get the index 1, you can get the location of this house already, right? This item already. You need to go from the first house, then see the index. Okay, this is 0, not the thing I want. Then I go to 1, or this is 1, this is the thing I want. Then I return it. So this linked list is slower in terms of reading compared to array. Right. So this is the difference when we want to consider whether the array list is better than linked list or not. It depends on the amount of read you have compared to write. Yeah, writing linked list is faster, but reading array is faster. Right. I hope that can explain your question just now. Wait, how is it? Right. Then another thing is about linked list. We have three types of linked list, or more than this also can. But in general, we have three types, right? So this is the singular linked list. So this is the doubly linked list with two arrows here. Then this is the circular linked list. Probably we can go from here to here and then to here, or backward also can. Okay, the only difference in general is that singular, you only have to manage the head. Yeah, so this is your head. You don't have to manage the tail, because from anyway you have to go from head in order to find the next node. So it's no need for you to manage the tail. Then you only can traverse in one direction, one way. Yeah, you can only go from first item to second to third. But for the doubly linked list, you manage both things. You manage the tail, head and tail, head and tail. The previous node and no, this is head, this is tail. So you can go from the last item, traverse backward. But the trade-off is that you have to manage another pointer to your previous item. Right. So now you can go to the right side and go to the left side. This is doubly linked list. And circular linked list is your tail is connected to your head. Yeah. So the tail is always pointing to the head. But this is another increment of performance cost as well. So you have to spend more cost in managing the tail connecting to the head and backward also, if you want to be like able to do something that doubly linked list can do. So when you are designing a program, there's no such thing as a perfect solution. Yeah, everything will have a trade-off, will have their cons. So you need to choose wisely. Yeah, you assess the risk, not the risk. You assess the cost first. How much it costs to manage this collection? Then only you choose which one is more suitable for you, right? Same goes to your assignment. Your assignment, instead of a very impressive UI, I I personally I'm more wanting to see how far you know the type of data structure, right? We are a literature course, we are not a designing course. So how you manage the data, is it efficient enough to solve the problem? Yeah, these kind of things. Then you need to provide your justifications. I'm not sure how the assessment will be like for this semester, but usually when we were asking about the performance scores, these kind of things, then how do you want, why do you want to use this data structure? Yeah. You need to be able to justify the way you use has these advantages and these disadvantages. We also want to know how you know about the downside of your program. Yeah, it's impossible for a program to be perfect, right? So moving forward, question 2. So question 2, we have to split list, alternate list, and merge list. Okay, I roughly see say the requirement first. So the first requirement is to split into half. So provided a list in the parameter, we want to split into two lists by cutting in the middle. Then the second question is that we want to put the odd number index into the first list and the even number index in the second list. The third one is we are provided two lists. Then we want to merge two lists into into one list and return to the user. But this time, we are using the alternate list. It means the first parameter, first list, first item, we put first. Then the second list, first item we put. Then first list, second item we put. Then alternate each other. Then D is asked us to reverse a linked list. Then this one is also reverse a linked list. I don't know what is the difference, but never mind. Okay. So I only roughly do the implementation to show you. Okay. So the first of all, the node that I'm using, okay, these things I don't need already. So the things I will need for solving question 2, if you still remember, we want to return two lists for the split list and alternate list. So I use the easiest way which I can think of to return two lists, because in Java you cannot do something like this. You can do something like, oh, I want to return the string at first, then I want to return integer in the second one. Yeah, this is not allowed in Java syntax. Yeah, that's why Java is uh its own way. Yeah, not very bad, but yeah. Okay, so if you want to return more than one value, you cannot do directly. So one of the ways you can do is you create another class, and this class you have two parameters, you have two variables inside. It contains two lists. Then this is another kind of data structure already. You make this to list class to hold the result returned by the method. Let's say I want two lists, then I'll put 2. One three, I'll put 3. Yeah, it's only an example of using the class to solve the issue that Java is not able to return uh, two values at once. Right. So this is list node. So again, I am not doing a generic linked list. Yeah, I'm just doing an integer linked list. So I don't have to worry about the technical side of generic elements. Yeah. But for you, I think you need to do it generic. And I believe you are able to find the source code for the generic linked list in your lecture slides. Yeah. So first, split list split into half, right? So this method, I put it inside my linked list class. So my linked list is a very long class which have some nodes and so on. Yeah. So this is a direct implementation of a linked list, my linked list class, right? Then you can see here in the split, I don't receive any parameter. It means that I'm splitting my linked list. Okay. I'm splitting the list that I'm managing inside this class. So I have two linked lists. Okay, I have two linked lists to be returned. At the first loop, I don't want to loop. So I don't want to loop until the end. I only want to loop from the index of 0 to the middle, because I want to split into half, right? So here I'm using a math.round. The reason I'm using this is because if I straight away use the size divide by 2, return, let's say if I have an item of 5, then 5 straight away divide by 2 will become 2.5. Then it will round down because of cutting everything behind the point, the dot, then it will become 2. Uh, so it will be until the index of 2. So the I being assigned to list 1 will be 0 and 1 will be only 2 items. But the questions already mentioned here, if the number is odd, the extra is inserted in the first list. Hey, what the hell? The extra is inserted. Okay, so the way I understand this question might be wrong. Okay, I assume that the things at the middle. So let's say if I have 1, 2, 3, 4, 5. Okay, so if it's an odd number list, I assign this 3 into the first list and this 2 in the second list. But apparently, we might also be able to understand the question as the extra node is this one, the 5. So it will be something like 1, 2, 5, then 3, 4. Yeah, so this might be another possibility also. It depends on the questions itself. So if you encounter such problem in examinations, just find a way to ask the lecturers or something like that. Because currently I'm doing this 1, 2, 3, 4, 5. Yeah, the end result might be entirely different, right? Anyway, I'm just cutting in the middle, then add it to the first list, and cutting into. Okay, this is a very dirty way of doing things, but never mind. Yeah, if it's an odd number, then I need to increase the temp, because here is given to the first list already. So I need to increment by 1 to give the element starting from the index of 3, right? So this will return 3 if I using a math.round. If it returns 3, then I need to start from 3 to give the items to the second list, 4 and 5, right? So there's nothing special here. I'm just adding to the first list, then add to the second list. Then I will return a to list that includes the list that already splitted, right? Then for the alternate list, this is much easier. So if it is divisible by 2, then I will add to the first list. Then divisible by 1, I will no, by 2, then I will remainder is 1, then I will return to the second list, then I'll return the list. Yeah, so this is for alternate list. Then for the merge list, this is a little bit awkward because I'm not using the linked list that I'm managing inside this class already. Yeah, I'm returning a new linked list that's nothing relevant to the current linked list. Yeah, so probably this kind of things can be static. Yeah, can be static method because I'm not using the variables inside already. Anyway, so merge list, I'm also using the toList class. This parameter, I can choose to have 2 different parameter like linked list 1, linked list 2. Yeah, because Java we can do multiple parameters, but we cannot return multiple values. Yeah. But anyway, I'm using the class since I already defined it. So this is a result which initially is empty. Then this is the total size, right? The definition of total size is the size of list 1 plus the size of list 2. Because at the end, after we are merging everything, supposedly we will have a list of size S, right? Then we have ijk. So this ijk, what does it mean? Hold on. So if you have problem seeing the screen or problem listening to my voice, then feel free to open your voice chat and tell me because I will not be able to see the chat, right? But moving on, the 3 variables I, J, K, all right. So K is a counter to count towards S, to count towards the size. I is a count towards the size of my first list. Then J is to count towards my second list. So actually, I don't think I need to define this because I already defined here. I think in Java, by default, the value will be 0. But anyway, I don't want to mess up myself, so I still initialize them. So initializations of ijk. Then here is the lengthy conditions. The first one, I need to ensure that k is less than s. This one also, I think I might not need to mention since I have these 2 conditions already. This one is I, while the items hasn't been all merging into my result list. And when my second list items haven't been fully merged into the result list, I need to continue doing this loop because there must be something that I miss out, right? So this is an AND condition. So what does it? So this implementation is very similar to a kind of sort called merge sort. Yeah. So I'm also merging something, right? So merge sort is using a similar implementation. Then I will only need k. So if the size is what is this? Yeah. So if it is divisible by 2, then from the first list, then I will increment the I index. Else I will get from the second list because I want to merge it alternately. Then I will increment the counter of j, which reflects the size of list 2. Okay. So because of my style, I tried to minimize the amount of things I need to type. So it might seem a little bit messy to you, but if you have a better way of understanding, then just feel free to implement in your own way. Then after I get out of this loop, it's not necessarily that I already merged all the items because there might be situation where list 1 has an imbalanced size compared to list 2. So for example, list 1 I have only 2 items, but list 2 I have 10 items. So when I get out of this loop, I only able to add like 3 or 4 items to the result list only. The remaining stuff in the list 2, I haven't merged yet. So I ensure that everything is merged. But the only things I can ensure for my implementation is that I can ensure that either one of the list is empty already. So that's why I don't have to alternate. So while I haven't get the I equals to the size of the list 1, blah 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 blah. Yeah. So I need to add the remaining items that I haven't added, and I will plus. Then here I'm doing the same thing for list 2. So let's say maybe I can demo here in terms of the value. Let's say list 1 I have this kind of items 1, 2, and list 2 I have 3, 4, 5, 6. Right. So at first, pulling in okay. I didn't do it very carefully. Maybe I'll be wrong in this the end result here. But agak it will be here like this. Okay. So let's say if out of this loop, I can ensure that I'm not sure the values remaining for 3, 4, 5, 6. Yeah, it may be 5, 6, it may be 4, 5, 6. Yeah. But the only thing I can ensure is 1 and 2 will be already merged into my result. Yeah. Because I'm this one time, then one time, then one time until the end. Then, but the 5, 6, I'm not able to merge it yet because I'm already out of this loop, right? Because the condition of I equals to size achieved. So I have to go out of this loop. Then from here, list 1, right? List 1 size, this is already achieved. So I do nothing. I didn't merge anything to the list. And here, after this while loop, this will be same 5, 6 because I do nothing for the first while loop. The second while loop, I will merge whatever that's left over in list 2 into my result. Then I will return the results. So this is for merging. Okay, we see a little bit of the implementation. And okay, so alternate list is this. And no need. After I run it, I can see, okay, here. 1, 2, 3, 4, 5. After alternate, I think the thing I left is, okay, alternate list will be 1, 2, 3, 4, 5, which is desired because odd number, right? And I code it in such way that it will alternate each other like this, 1, 2, 3, 4, 5. Yeah. So alternate list done. Then we can try to see split list. So split list will be splitting at the middle. Yeah, just now I think I say wrongly for the alternate. Never mind. So it'll be 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. So both are working. Then what else we can do? Merge list. Now so at 1, 2, 2 merge list T1, right? Let's try this. Okay. So initially we have 1, 2, 3, 4, 5. Then I have another list, I think. Okay. So I think I need to do this. I need to print out to be more obvious. Then after this list 1, I need to put it elsewhere here. Okay. Right. So this is the second list. This is the first list, right? So this one is the original list. Just ignore it because I need to split it into 2, 4, 5 here, then 1, 2, 3 here. So for your information, this is list 2. This is not list 1, but list 2. This is list 1. Okay. So these two lists, I want to merge them in all the first line. So first of all, I will go for list 1 first. Put it down, then here, put it down, then 2, put it down, 5, put it down. Now we have reached an end where the second list is empty, but the first list has 4 more items, right? So these 4 items will be simply put at the end, at behind all my existing results, and I will return the result. Right. I hope this is clear for you, because we initially alternate 1, 1, 4, 1, 4, 2, 5, but at the end, the remaining will be simply append to the behind, right? So this is for merging. Now we need to move forward to the reverse linked list. Okay. So now we have an array of 1, 2, 3, 4, 5 because this is add sort node, right? So it's sorted 1, 2, 3, 4, 5. Then reverse, I only do it here. So it asks us to use a recursive way of reversing an array. So again, recursion is something like we do a repetitive task until the stopping condition. So in this case, my stopping condition is when I already process all of my items in the linked list, right? So the sequence in these 3 lines is extremely important. It can define our end result. Okay, so here I just make the array item, this node, into a temporary node first. So later I can show you in Paint again. Then I will call a recursive method. After it reach the stopping condition, it will traverse from the final method back to the first method. Then when it traverses back, it will add the temporary node back to my list. So in that case, I will be adding the last method that I've called, which when the size is equals to 1, I will add to the array list, not the array list, add to the linked list. Then I will add the second last one, then the third last one until the end. And at the end, I should get a result that can help me to reverse my linked list. Yeah, reverse my linked list. So yeah, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. So I'll explain in pen here. So this is a recursive method, right? So I believe that today you have learned in tutorial what is stack. So stack is something like a simulation of your Mr. Potato, right? So let's say this is your potato chips. Then probably something like this. Okay, so this is your potato chips. So whatever chips that is down here, at first when they are putting the chips for you, right? We put it down here, it will be something like this: 1, 2, 3, 4. Then when you want to take it out, you will take the topmost first out. Yeah, when you want to eat it, right? You take one by one, or you take it at once. Yeah, but anyway, the first chips that's going from the potato, from the container, will be the topmost, which is the latest chip they have put in, right? Then the oldest one will be the status. That will be the last one who go out from the container. So this is a implementation of stack. So it's simulating this situation to cope with our real life problems. So as you can see, it is similar to, it depends on your implementation, but it can be implemented in the linked list way by limiting the capability of a linked list. Anyway, we don't talk about the to detail it first. So why am I talking about stack? Because just now we are reversing a linked list, right? So at first, our linked list is something like this: 1, 2, 3. is linking with each other. But every time when I traverse my recursion, I will make this isolated first. Then I'll make this isolated. So this is the first stage. This is the second stage. Then I'll make this isolated. After this, all are isolated. It means my linked list is already empty. I reach the stopping condition where my size is 0. Then only I can go to a second stage. Right? So after I go to a second stage, because of the behavior of the recursive method, it is like a stack. The latest method will be called first, then traverse up to the second latest method call, then until the first method call. So what I mean is that, so if let's say this is already done the stopping condition, it is getting closer. It's getting close. So this thing will be append to a new linked list, which is something like this. Append to a new linked list. So this is a linked list already. This is a linked list. This is a third stage. After the stopping condition has reached, then here is a second last method call. I will link it back. Then here I will link it back again. At the end, I should get a reverse linked list, right? So we can see a code again here. The things that do the magic is I catch it first. Yeah, I catch the things that have been removed at the index 0. It means the 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 first element in my linked list. Yeah, I remove it and I catch it first. I don't do anything to it first. Then the second one, I don't do anything. I isolate each and every item. After I reach the stopping condition, if the method is not yet returned, it will call this. It will add back whatever I have removed from my array list, my linked list. Sorry about that. Then add back into the list. So another theory that you need to be careful when you are doing this, yeah, when you are thinking why it will work, is that this is passing by reference. Okay, so this concept is again is very important. So yeah, I don't want to save it. Okay, so this concept is again very important. So in Java, we have, okay, I don't want to use pen, I decided I can use a notepad. In Java, we have method call, right? So this is a method, this is a parameter, this is some type. So in the parameter passing, we can pass by value or pass by reference. These are two core concepts of passing things as parameter. And what I mean by pass by value is that when you pass, for example, you pass an integer inside the method, right? The integer value, if you reassign it to something else, it will not affect the original things that you have passed in because it will make a copy locally in that method, right? So this is for primitive type. What is a primitive type? It's integer like string probably. Yeah, I'm not sure if string is, yeah, don't write it first. Double float. So these kind of things are the primitive type of Java. It means they are the smallest element that the Java data can have. So these things, if we pass into here, let's say if we pass an integer x, we pass an x here, we define the x in our main method, and we call the method called method integer x. This x will be copied here. So when you are setting, let's say you are setting the method x equals to 1. This x equals to 1 will not reflect to our original x. It means even if this is 1, this x is still its original value. Like for example, it's 100, then it will still be 100. The reason is that this is passed by value, right? Passed by value means I have an original copy inside here. So there's nothing relevant to the main method already. Why am I explaining this? Because just now we are passing by reference. Passing by reference is another it's another behavior than the passing by value. So let's say if I have this, so this is for all the classes that we have implemented. So for example, my linked list. We pass my linked list inside here. Then we assign my linked list X into something. This one will actually be reflected to our original my linked list. It means this X will also be one already, right? As you can see, we pass by my linked list. Then here I assign something. I don't return anything, yeah. But still this will become one because they are passing by reference, which is something like passing the original item inside the method. As you can see, because this my linked list is my class. Yeah, the class derived myself. Then if I as a parameter, this array will be the same whatever many times of methods I've recurved. So every time the recursion done, I will still be using only one item. So simply the array is only I only have one array for the entire reverse call. So this is why it will work out. Like I remove here, then the original array will be removed. I add the original array will be added, right? So it's a very useful stuff when you understand the concept of passing by value and passing by reference, right? So this is for reverse linked list. This tool, I think maybe they want us to implement the list inside the my linked list class. Then it should be using some kind of node to reverse the list, but it is really cumbersome. Yeah, to using a node to shift this question. So it's a matter of layer of difficulty. Yeah, this method it might not be the most way, but it's simple. But if you are moving it inside and you are interfering with the underneath current node, it means that you are mixing up the most lower level of the implementation, the core implementation for the linked list. It is okay, but it will be sort of confusing. So if you're not careful with dealing with nodes, you might end up to messing up your own codes. Yeah. So this is not something that we hope to see. Yeah. So there's a reason I hide the complexity of removing, of adding. Yeah, I don't mix them together with a trade-off of the performance. Yeah. So that's it for second question. Sorry for taking too long. I will pass the rest of the question to where is it? Okay. So I will pass the questions to Xia. Right. Stop presenting it.
Okay, everyone. I will take over for question 3. Okay, so now I will share my screen. Okay, can everyone see?
Yeah, can see, can see.
Okay, so for question 3, you need to create a linked list, a single linked list, and then you need to create a cost, and then wait. Sorry, presenting my whole screen. Okay, so for question 3, you need to create a class cost. They have the course code, course name, credit hours, and the grade. And then the point will be 43210 for ABCDF. So that you can insert the information into the linked list, and then you calculate the grade point average. Okay, so So for this one, the course will have course code, course name, credit hour, and grade. So this is the constructor, setter, getter, and then lastly the toString. So if this course is what we call as a reference object. So if you did not have a toString method, it will print out the reference address of this object. So instead of course code, course name, credit hour, and grade, show. Okay, so it will be something like this. This is the reference address of the course object that it currently pointing to. So if you want to print the course object, you will need a toString method. Okay, this one is a linked list. So this one is a not object, and then I will set the variable to private, and then use the getter setter to set and get the variable, and then finally same as the course object, it will need a toString method as well, so you can print the object out. Print the content out, but not the this one is what usual like implement like the slide. So if you have get first, get last, get for get you can reuse the method you have write before. Like get first, it will you can just return get first, and get last, you return get last. For this one, if the index is outside of the linked list, I will throw an exception which index outbound exception. And then at first, at last. Actually, for this question, implement the add operation only. It doesn't have the remove operation. So in exam, to save your time, you don't need to implement all like what I do now, which I have the remove first, last, remove last, remove. I guess I need. Okay, so the remove operation you do not need to implement. You only need the add operation so that your program can run, can get the correct result. And then get size, and then finally the toString method, so that I can print this linked list out. Okay, wait. Okay. To implement this one, the total point, total credit, and grade point average everywhere. It just asks us to calculate the grade point average for the student. So for to get the grade, I will do it in the main, which I create a static method which get grade, and then I pass the list, the linked list we created in it. So first I will I will initialize the total point and total credit to 0 first. And then for and then I will get every course object inside the list. I will use the switch this one, the point allocate to each grade 4, 3, 2, 1, and 0. And then I will add it out and then print it out. Okay, so in what we see in the question is this one, the grade point average is actually 2 decimal place. So if we so what we do right now, we put inside it and then we try to print it out. So actually it will print to make it look formatted and as the question, I separate the variable out, and then I use the printf function of the system out the print, and then I input the PA here. Okay, I'm not sure what. I think you all have learned before how to use the printf. The percent. So if we want to print the double or float, we need the percent f. And then if we want to print 2 decimal, and then the /n is to add the line separator, which is it will jump to the next line. If we did not add, the build successful will be continued in the same line. Okay. So this the question 3. Okay. And for the wait. Okay. For the main, I will have at first, at last, and add. This one is to test all the method I write is correct or not. And it show it is correctly as the question. Yeah. Except that maybe you have some, if the space different with the question only. Okay. There's and for question 4 actually is quite easy because it actually doesn't ask you to, you can just make a normal linked list, and then you use the random number generator. You generate for each player, each turn, if you generate a number, then you keep at last only. And then when the end condition will be when the player have more than 20 stars in the list. So you just create two linked lists, and then one for player 1 for player 2, and then you see which player reach 20 star in the list first, and then you print that player win the game. Okay, that's it for say is about this. Actually, from what I see, actually, some of our people may not understand why. How do you define the type of the list or other data structure type, like maybe a set, okay, or what you learn, a stack. Okay, actually you can change this one, which is the type. This one is indicate the type of the of this data structure, which stack. This one is stack, and then this one is it will store the cost object. And then for second one, it will store integer object. You just try to change the data type in the bracket is okay already. And then you do not need other operation. Okay, that is all from me. And then I will pass to other demo.
Okay, I'll quickly go to the question 5, right? Present now again. This time I will be faster, right? So question 5, it asks us to create an iterator. So iterator is something like a class that we can do for looping, right? Iterate to loop through all the elements we have in the linked list. So it's called linked list iterator. Then we need to iterate through some kind of strings, then do some removal, I think. Then yeah, then that's it. Yeah, you only want to test our knowledge in iterator only. So I will only focus on the iterator. And again, it is in integer because I'm lazy. I don't want to follow the question. Yeah, just want to explain the concept. So this iterator, let's say this is the class, my linked list class. Inside here, we have an inner class. So inner class is a class inside another class, right? So this class, it implements iterator, which by default, we have to implement these two abstract methods, right? So the good thing of inner class is that it has access to the outside, the variables that is maintained by the outer class. So for example here, at first we are having a current index of -1 because we haven't looked through any items yet. So has next will return if a current index +1 is inside the range of the list or not. So if it is a list size of size 0, then 0 is less than 0, right? So it will return a false. If the size is 1, then 0 plus 1 is a negative plus 1 is 0. So 0 is the size, it will return a true. So then for the next the has next method is defining whether we are just having some more items that we iterate through or not. The next method is to return the next item if we have any. So again, I will handle the edge conditions where we don't have next item already. I'll just return a -1. Else I'll return the method of my linked list, then with this prefix incrementation. So what does it mean? It means that I will call this first current index plus plus. Yeah, I will plus the current index. Let's say if it's a -1, I will plus it to become 0. Then I will call get. Yeah, get 0. Right. So I think what's it? Okay. Yeah, that's it. Again, I am sacrificing the cost for the ease of codes, right? Because I'm using the get method that the complexity has already been hidden in the outer class. So I don't have to worry about managing the nodes again, right? If you want to manage the nodes, yeah, feel free to do so. But because I'm not confident with with my skill level, so I just use the index to manage my iterator. Then how do we want to call it, right? So we are getting my linked list. So this is how we want to initialize an inner class. So it's an outer class, my linked list dot linked list iterator. Then I will make a variable, then array dot new, right? Dot new. So this array is a object that's already been initialized just now, right? Then I will create a new iterate. Then let's say if I can run it, right? I'm calling bunch of next. So the first one is if it is still having my the next item, yes it is. So I will look through 5, 4, 3, 2, 1 accordingly by calling bunch of dot next. Then after I reach an end where the last item is already been iterated, I'll return -1. So this is the desired output, right? So that's it for question 5. Then if you want to to solve this problem, probably to again same thing. You need to implement the remove. Then depending on this questions, depending on the questions, you might want to set it into the type of string or character. Yeah, I didn't. The list consists of. It seems like. Yeah. Is as a string. So this is item 1, item 2, item 3. Then we are using an iterator to loop through every item and remove the current item if they are containing A. Yeah, so you may tweak it in as you want to, right? So that's it for question 5. I'll pass question 6 to Asia. Or Asia, right? Stop presenting.
Okay, so I will continue with question 6. Okay, so for question 6, you need to create a double list node and then and also a double linked list file. And then you create a tester class that generates random number from 0 to 100. And then and you insert a number into the linked list and perform the operation as follow. So first you remove a number in 7 position, and then lastly the remove all even number from the double linked list. Okay, so we will start now. Okay, so this is the double list node in my implementation. So it's actually same as the node class, but the only thing different is it have the previous, it will have a previous node as well. Okay, other thing, I will have the getter and setter for the variable, and then lastly the toString as well. And then for the double linked list, is actually almost same with the linked list, but you need to when you add or remove the node, you need to set the previous as well. So set the reference object of the node object of a previous. Okay. For the double linked list, I have 2 constructor. The first one is empty constructor, which I initialize the linked list to with 0 element, and then for the second one, you can pass in an array, and then you will add the element of array inside the linked list. Okay. At last, I will return the. At last, I will use back the at first if is still is now, which means it doesn't have any element inside. And then for add, okay. So okay. So for add method, you actually what you need to be careful is the index you need to jump to. The first two are if index equal to 0 or index is larger than size, larger or equal to size minus 1. If you want to add the index not in these two conditions, you need to be very careful. First, need to create a current node with your head node, and then you need to jump to the one place before the index. So let's say so for head node is actually start with 0 index. If the index we want to insert is if the index we want to insert is 1, which just one is after the head. So actually you do not need to jump. You just jump to the head. Okay, yeah, you just jump to the head, and then you can just and then set next to this new node. So you create a new node, which you just initialize it with the nest of a current, and then your current will be your previous node. But you need to remember to set the reference of your next node, the next node, and then the previous node to point to this new node. If not, this new node will not be displayed because it's being bypassed. So for remove first, if okay, so here I use the no such element exception, which indicate that if the list is empty, then there is no element inside the list. And then it's quite similar to the linked list, but except that you need to set the previous node of the new head node to now, so that when you iterate from behind, you do not print the old head node, which supposed to be deleted. And then remove last cell, you need to the node that you delete. So you need to set it to now with the new head tail node. And then for remove, if the list if the index is out of the range of this list, then you should throw the exception as well. Actually, this one depends on your implementation. If you want to let user to get the still can get the without get the object without get exception, you can just return now. But here I choose to throw the exception to there is no such element inside it. Okay, for the remove method, actually is a bit different than the linked list. For remove method in linked list, I use I jump in front this of the node that I want to remove. But for the double linked list, I straight jump to the node because I can get the next node and the previous node, and then I just set the reference of these two nodes to each other, and then I destroy the reference of the current node to the next node and previous node. The data inside the current node. Okay, for I think I'm not sure whether this one is in your slide or not. But actually it's very simple as well. You just jump to the node and then you replace the element. And then lastly is the toString. A toString method to print the list. Okay. Okay. First of all, you need to create an array of 10. Or you can for this one because I have created a constructor that you can input the put it inside here. Okay. I just generate the array at here, then I put it inside the constructor. But for this one, actually, you need to be careful of one thing, which is if you put inti, it actually tell you cannot import type argument for double linked list. If you put integer here, we actually say that inti cannot be converted to the integer. Is telling you that the primitive type cannot be converted to the integer object type. So to overcome this problem, you will need to change the type of the array. Integer object. And then so there are three operations. The first one is the remove. You can use the remove. You can use the remove operation inside the double linked list. Yeah, the remove with the index. So you just remove. Okay. So you need to remember to -1 for the index, because the index start with 0, so you need to remove the second. remove 2, we remove the third element. And then for the replace is same. You just you can use the replace method if you have then you replace with 6. Okay. So now let's go to the last one. We remove all even number from the doubly linked list. Okay. Actually, for this method, I will choose to add here. For this method, the remove even method, I will put inside the main. Because what I implement is the generic. If you implement is not generic, if you implement the integer type, you do not need to specify. If you implement integer type, and you do not have this problem, but for this, if you implement the generic one, so if you try to operation, it actually it will show you the error, which is the type error. Because for this one is actually the generic type. It cannot ensure it will be integer type. So if you want to, it's better you put it inside the main. Which this one, the generic type, you can reuse for other question. Wait, I need to implement the get first. And here, if you specify the type, it will be okay. If you did not specify the type, because it cannot ensure that is an integer type, it will return a object type. So you need to specify a type. Okay. So for this method, I will check when first I will declare the current, not which, and then I use the index. This index is served as which index now I am accessing, and then I will, if the index I'm accessing in is a even number, so I will remove this index. If it is not, I will increase the index and then jump to the next node to continue checking. Now try. Okay. 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 So first one is 20, so it should be removed. Okay, the problem is a null pointer abstraction. We need to check whether our method implement correctly or not. Okay, this one is next, previous. So if you want to debug, we need to bring it up. Okay, so for this one, actually, it jumped to the end already. Okay. Okay. So for this one, the remove first, if we print out, actually is removing it. But what we can see here is it actually try to remove everything. So it means something wrong with this. Uh, Need to debug here. Oh, okay. Sorry. This one have problem a bit. Actually, this is a bad way to debug. So you just print. Actually, if you want to really debug correctly, you need to use the debugger of a project. Okay. So the problem here is actually I did not if I remove the index already, I did not get the current of still the same, but we need to put it in front her first. Okay, then it will work correctly. This is because when we remove the index, but we did not move our current object to the next pointer, it will just now actually you can see that for the last field, it is actually still the same integer with 70. It indicates that we did not jump the current node to next node. So this will become a problem. And then now we change this, we jump to the next node first and we remove the index. And then this will become correct already, which all even number. 999 and 57. Only these four left. Okay. Okay. So it's implemented correctly. Okay. That is all for question 6. Okay. I will pass to other demo.
Okay, I will continue for the question 7. Okay, so for question 7, the question requires us to create a circular linked list which contain the following methods, which is length, so you can know the size of the circular linked list, and you can add a item at the back and delete the item from the back, and show the list probably for this one we will do it like to string. So we will get the string representation of the circular linked list, and then we print it out. And also lastly is the get item, get by the index. Okay, so for my circular linked list, I'm doing quite similar with the question one that I did before. Just got some different is I'm using list not method instead of a single list not, because the question didn't mention, so we can either using single or double. So when if I'm using the double list not, I have only the pointer for the head. I don't need a pointer for the tail, because I can use the head dot previous to look back the tail of the tail of the circular linked list. Okay, so basically we have some method that is required for inside the circular linked list. So the first one is the add item. So for this one is quite similar with the normal linked list. Just you need to take note for the every time when you add on to the last value, right? When you link the tail to the new value, you need to link the new value to the head also. So you need to ensure your head and the tail is always connected, so it can be a circular linked list. And then for delete circular item, so we delete for the tail, which is the previous of the head. So we will get the new last element, which is the previous of the head. And we get the data from the tail, which is the previous of the head. We get the value, and then lastly we will return the value. So before we return the value, we will unlink the value that we want to delete by connecting head and also the previous of the tail. The remove sorry, I mistaken, misunderstood the question. So actually for the remove, we need to remove by the index. Okay. For remove by the index, right? So for one thing that we need to take note is whether we remove the head or not. Other thing is just like a normal operation. So when you remove, you will link the previous and the next value together, and then you drop a value. So you get the previous, you will get the current node until you get the particular index that you want to remove. So you will get the previous node and the next node, and then you link them together, and they will return the value of the current node. But before you return, you need to check whether the value that you are remove, it is the head of the circular linked list or not. If it is the head or tail, so you need to set the new value for the head or the tail. Or if you didn't do this operation, probably you will lost the whole value of a linked list, since the pointer is missing. So here I check for the if the current node is equal to the head, so that means the head will be removed. So I will set the head into the new value, which is the next node of the current node, and then we will return the value that we deleted. Okay, so for the get method is similar with the operation in the remove, which is you loop through until you get the current node, and then return the value of the current node. And then for length and string. Okay, for length, either you have two way to do the length. Either you have a counter value, where when you are adding any value inside the scaling list, you will add on the pointer or delete the pointer. So you are always tracking the size of the scaling list. So when you want to get the size, you will just return the value of the counter. But I'm using another method where I look through from the head to count how many element inside. So if you are not using counter, if you are using if you are counting from a head to the tail, so one thing you're gonna take note is you need to check to ensure the current node. If you are using if you are doing normal linked list, you will check if the current node is equal to null, so it means you already reached the end of the node. But for the secure linked list, since the tail is connecting to the head, so you won't able to get current node equal to null, so because it will always repeat. So in order to get the stopping condition, so you will check whether the current node is equal to head. So if you reach the head again, that means you already complete the one circular. So that means you already reach the end of the circling list, and they will return how many count that you have counted. Okay, same as the toString method. So for toString method, when you are doing the while loop, so you will check whether the current node it is equal to the head. So if equal to the head, so that means you already complete one round of a circling list. So at the end, you will just add on the value of the head. So this means you will end the value of n. The last value will be the first value. So when you add on the string, after you found that you reach the end, so you add the first value inside at the last of the string. So when you return, then you return the string to get the representation string of the object. Okay, now we test the scaling list with the main method. So in here, I didn't follow a question using a string. I'm using an integer because I take my main class from a question one and modify. Okay, first we get tens random numbers. So we push all the random numbers to the securing list, and then we print it out. Okay, so here you can see the last value will be same with the first value. Okay, then I try to check the functionality of the remove and the get, whether they can get the correct value or not. So if I delete the third value, the third item. So the third item is at the index number 2. So I remove the index number 2. So basically I will remove the 64. So the 88 will link to 90, and 90 previous will become 88. And when I want to get the third value with the index of 2, I will get a value of 90 instead of value of 64. So most of the thing will be similar with the ordinary linked list. Just we need to take note that some of the operation that we need to take care is when you are reaching the end of the nodes, since the end of the linked list will link to the head, the start of the linked list. So we need to know when you complete one circle and come back again to the start of the linked list, then you need to stop the operation. Not you will like go to an infinite loop, like for the get the like the toString method. So if you loop through, if you check the current node is equal to null, so it will become infinite loop, right? So any question until now? Okay, so if don't have any question, then I will let Sia to proceed for the question 8.
Or maybe just in concept. I think the time is up already. So yeah. How about Sia explain a little bit about the concept? Yeah, why we are using circular linked list. Oh yeah. Before that, never mind. Let me share my screen. Okay. A little bit. Okay. So for the question 4, where is it? For for question 8, it provides us snippets, right? So this snippets is actually not always going to work. So the reason might be due to, for example, if you are using a Windows 10, if your username has some spaces, so it might have problem that you cannot find this file specified. So hopefully that you are having a username without space, and also the file path, the folder name, these things needs to be without space. For case because just now I tried with spaces, I can't actually play my music, but if I remove, yeah, it was working fine. Yeah, so that's it. A little bit of add-ons only for these questions, right? So anyway, this question is using a singular linked list, which is because we want to traverse from the final song to the first song. Yeah. So this is only the reason. So we can maintain head and tail for every song. Not head and tail. Yeah, previous and next of every song. So we can move from one song to another easily, and from one song to previous song easily, and also from first song to the last song easily by using dot previous, something like that. Yeah. So to solve this question 8, we not necessarily we need to use need to maintain the index, not the index, the size of the linked list. Yeah, I think we can without having any index, but not sure about this. Anyway, this question is about circular linked list. Sia, do you have any add-ons for this question?
No. I don't have any
Okay.
add-on. is
I think yeah, time's up. Right.
okay.
Mm. So yeah, I think that's all for this lab first. If you have any problems, then feel free to raise the issue. Whether you can, yeah, right. So anything we can, just feel free to ask us. We will try our best to explain. Because this lab is very many questions, so we might be missing out the details, and only focus more on the concepts. Yeah, when you're implementing, you face any problem, then can discuss together also. Yeah. Right. So I think that's it for this section. Yeah, we'll pass to Doctor.